Hello everyone, my name is Avery Dutcher and today I'll be presenting our research titled The Effects of High Salt Diet on Blood Pressure and the Renal Handling of Sodium. Hypertension increases the risk for numerous pathologies, particularly stroke and cardiovascular disease. Numerous causes of hypertension exist: genetic, environmental, lifestyle, etc. High salt consumption is prevalent globally and is one of the well-known causes of hypertension. The American Heart Association, American College of Cardiology, physicians, and general health professionals recommend reducing dietary salt consumption, although this is difficult in our society. The renal system is responsible for excreting excess salt from the body and preventing salt-induced hypertension. Sex differences in cardiovascular and kidney disease are well documented, with females being protected compared to their age-matched males. Thus, it is important to study sex differences related to the control of blood pressure and in renal function on how the kidney excretes sodium under high salt consumption. The purpose of this study was to investigate sex differences in the renal handling of sodium and blood pressure in mice during a 30-day period of high salt consumption. Based on previous data, we hypothesized that female mice would demonstrate lower blood pressure and excrete less sodium than males during this 30-day period of high salt consumption. Methods included female and male mice at 12 weeks of age being placed in metabolic cages with access to food and water. Daily measurements included body weight, food, water intake, urine flow rate, and urine sodium concentration. Blood pressure of each mouse was measured periodically via the tail cuff method. This method uses a restrainer and a warming platform to maintain normal body temperature. After a 3-day training period, mice became accustomed to the restrainer, ensuring that blood pressure was recorded under minimal stress. Quantitative real-time PCR was employed to measure relative expression of key sodium transporters in the kidney. Kidney tissue was harvested from separate mice placed on the same dietary protocol as those in metabolic cages. Total RNA was extracted from renal cortical tissue using MELT nucleotide kit, and cDNA was synthesized using the RT-squared first strand kit. Real-time PCR was conducted using PCR arrays designed for specific primers for mouse sodium transporters. This figure demonstrates periodic systolic blood pressure measurements in female and male mice. As you can see by the graph on the right, male mice had a statistically significant higher systolic blood pressure. Additionally, female mice excreted less of the ingested sodium and thus retained more sodium. Also, female mice kidneys had high expression of key sodium transporters such as NKCC transporter, suggesting an explanation for the higher sodium retention during the high salt consumption. In conclusion, that we have shown that despite a higher sodium retention, female mice have lower blood pressure readings than male mice. This supports that there is a protective nature of the female sex during periods of high salt consumption, and that sex steroids play an important role in the renal handling of sodium and blood pressure. If you have any questions, please reach out. Thank you so much.